Greetings, my name is Natalia Montemayor, and welcome to another lecture from the 2020 Honors Chemistry Short Lecture Series. Often, when we think of recycling paper and aluminum cans. But what about recycling glass? Very few people recycle glass, even though glass is 100% recyclable and can be recycled forever. In this presentation, I will be discussing glass recycling. My inspiring CNDN article is Why Glass Recycling in the U.S. is Broken. In this presentation, I will begin by briefly explaining my inspiring CNEN article. Then I will explain the glass recycling process, which includes cullet XRF, which is the instrument/machine used, and the ingredients needed to make glass. I will then talk about the composition of glass and colored glass. Lastly, I will conclude my presentation with an analysis and summary of my research. The last slides will have my sources for the presentation. The title of my CNN article was Why Glass Recycling in the U.S. is Broken. Glass is 100% recyclable, yet in the United States, many Americans do not recycle their glass. According to the CNN article, the U.S. has a recycling rate of 33% compared to the 90% in Switzerland, Germany, and other European countries. This is mainly because U.S. municipalities manage residential recycling primarily via single-stream curbside collection. Single-stream collection is when recyclables are all put in one container, meaning aluminum and steel cans, various types of plastic, newsprint, junk mail, cardboard, and other paper products are all collected together. On the other hand, multi-stream collection is when recyclables are separated by material type before they are collected. 40% of glass from single-stream collection ends up being recycled into new products, compared with about 90% of glass from multi-stream systems. For this reason, with the U.S. using single-stream collection, there is a limited availability of satisfactory cullet for U.S. glass industries, which stands in the way for them to boost recycling numbers. So, why doesn't the U.S. just follow what the European countries are doing? The big difference between the U.S. and European countries is size, as the U.S. is much larger. Distances in the U.S. between a materials recovery facility and a cullet supplier, or a cullet supplier and a buyer, tend to be greater than in European countries. Now, I will begin by explaining the glass recycling process. First, glass is collected from recycling bins or is deposited at recycling centers. From there, it is transported to a recycling plant. At the recycling plant, the glass is sorted by color, meaning red glass is put together, blue glass is put together, and so on. This must be done as mixing glass colors diminishes the quality of the recycled product. Then, once the glass is sorted, it is washed so that it can begin to be broken. When the glass is broken, cullet is created. Cullet is a granular material made by crushing bottles and jars. Next, the cullet is mixed with other materials like limestone, sand, and soda ash, which are then put in a furnace that is over 2,600 degrees Fahrenheit. It is heated to such a high temperature because the melting point of glass is very high, as it varies from 1,400 degrees Celsius to 1,600 degrees Celsius, depending on the composition of the glass, which in Fahrenheit is 2,552 degrees Fahrenheit to 2,912 degrees Fahrenheit. Once the glass becomes liquid or molten glass, it is poured into a mold. It then cools to form a finished glass product. Most recycled glass is used to make glass containers such as jars and bottles. Other products that use recycled glass include fiberglass, insulation, ceramic tiles, and a variety of construction products. What is cullet and why is it important in the glass recycling process? Cullet is a granular material made by crushing bottles and jars. So, in simpler terms, it is crushed glass. On the side are two images of cullet. Cullet is important in the glass recycling process for the following reasons. Adding cullet to the feed mixture improves the quality of glass products. Adding the material to the mix reduces greenhouse gas emissions during manufacturing, which saves energy costs. For every 10% of cullet included in the glass-making feed mixture, the energy needed to keep the furnace at temperatures high enough to generate molten glass falls by nearly 3%. Recycled glass cullet accounts for 70% of the raw materials needed to create the millions of glass containers used every year. Cullet allows glass manufacturers to reduce their need for raw materials. 1 kilogram of cullet replaces 1.2 kilograms of raw materials. So, cullet plays a major role in glass recycling. Unrecyclable glass materials such as ceramics, crystal, and clay garden pots are increasingly common in a variety of products, including cookware, manufactured goods, smartphones, and they can contain contaminants that are harmful to our health. Even if no harmful contaminants are present in the unrecyclable glass, most have different chemistries and a higher melting point than regular glass, which can potentially cause damage to the glass furnace and cutting systems and create impurities in new glass materials. For these reasons, these materials need to be separated out. X-ray fluorescence, or XRF, is a technology that can be used to determine the material chemistry of a sample. It is able to detect and separate the contaminated glass fragments from recyclable glass by chemical composition. For example, it will recognize ceramic identifiers such as zinc, titanium, and lead. The Extreme Inline X-ray Fluorescence Analyzer can process as much as 28 tons of glass cullet per hour. It's designed for high volume and uses multiple detector arrays so that even small fragments can be reliably separated. It sorts glass cullet as it passes under the arrays and separates contaminated fragments from safe glass using a blast of air. These images show how it works. In the first box, we can see the detectors and the X-ray tubes, and below is the singulated mixed scrap, or the unsorted glass. In the next box, the X-ray tubes excite the material, meaning they bring out the materials. Then in the last box, it shows how the detectors catch the emitted fluorescent X-rays. In order to create or make glass, these are the ingredients needed. The main ingredient for glass making is silica, and it has a very high melting point of over 2,000 degrees Celsius, which is 3,632 degrees Fahrenheit. Then there is sodium carbonate. Sodium carbonate lowers the melting point of silica to 1,000 degrees Celsius, which is 1,832 degrees Fahrenheit, therefore making the process more efficient. Sodium carbonate is also known as soda ash, since it can be extracted from the ashes of plants. Adding the sodium carbonate will cause the finished glass to be water-soluble, which is not desirable in glass making. However, the next ingredient is lime or calcium oxide, which helps solve this problem. Calcium oxide is extracted from limestone and counters the effects of the sodium carbonate, making the glass non-soluble in water. Other ingredients can be added to change the properties of the finished glass product. Some examples of additives are boron, lanthanum oxide, and iron. Boron changes the thermal and electrical properties of the glass and is used to make Pyrex glassware, which can withstand extremes of heat and cold. Lanthanum oxide has excellent light reflective properties and is used to make high-quality lenses and glasses. Iron is used to absorb infrared energy in, for example, heat-absorbing filters in movie projectors. Lastly, a range of additives can be used to make glass with different colors, which I will explain in more detail later in the presentation. Next, I will talk about the composition of glass. When looking at the composition of glass, it is important to know that there is no single chemical composition that characterizes all glass. According to the Corning Museum of Glass, typical glass has formers, fluxes, and stabilizers. Formers make up the largest percentage of the mixture to be melted. In typical soda-lime silica glass, the former is silica, silicon dioxide, in the form of sand. Fluxes lower the temperature at which the formers will melt. Soda, sodium carbonate, is a common flux. Stabilizers make the glass water-resistant and strong. Calcium carbonate, often called limestone, is a stabilizer. Without a stabilizer, water and humidity attack and dissolve glass. On this slide, I will be specifically discussing the composition of soda-lime silica glass, as this type of glass makes up 90% of manufactured glass. It is usually used for window panes and for glass containers like bottles and jars, for beverages and food. The composition of soda-lime silica glass is normally 60 to 75% silica, 12 to 15% soda, and 5 to 12% lime. Glasses begin as mixtures of oxides, as we can see in the table on the right. Looking at this table, we can see that silica, which is sand, is silicon dioxide. Soda, which is soda ash, is sodium oxide. Now, this might seem as though I'm contradicting myself, as earlier I had said that soda was sodium carbonate. However, when sodium carbonate is heated, sodium oxide is produced. Lime, which is limestone, is calcium oxide. Potash, which is ashes of inland plants, is potassium oxide. Boron, which is a mineral, is boric oxide. Lead, which is an oxidized lead metal, is lead oxide. Then, on the table on the left, it shows how much of each component there is in soda-lime silica glass using weight percentages. So, in this example, soda-lime silica glass is made up of 73.6% silica, 16.0% soda, 5.2% lime, 0.6% potash, 3.6% magnesia, and 1.0% alumina. Iron oxide, boric oxide, and lead oxide are additives of which I explained earlier that are added for specific purposes in different glass products. However, they are not added in soda-lime silica glass. Now that we know how glass is made, how does glass become a specific color? I had briefly mentioned this at the beginning of the presentation when speaking of the materials needed to make glass. Colored glass gets its color from metals. The key ingredients for making colored glass are metal oxides. Although not all of them are oxides, most of them are. The following list shows how by adding different metal oxides, it will produce a specific color for the glass. Adding cobalt oxide produces a blue-violet color. Adding cadmium sulfide produces a yellow color. Adding gold chloride produces a red color. Adding antimony oxide produces a white color. Adding sulfur produces a yellow amber color. Adding uranium oxide produces a fluorescent yellow-green. Adding chromic oxide produces an emerald green color. Manganese dioxide, sodium nitrate, and other certain compounds produce clear glass when they are used with certain types of molten glass to remove other impurities. Lastly, I will wrap up my presentation with a conclusion. Glass recycling can have a large impact locally, nationally, and globally. It is up to people to make the effort to recycle their glass. Now, knowing the composition of glass and the process by which it goes through to be recycled, we can see that by recycling the glass we use every day, we really are making a difference. If more people, especially Americans, were to recycle glass, a lot of raw materials could be preserved, and it would help the environment by reducing carbon emissions into the air. Unfortunately, the U.S. has made it harder to recycle glass due to its large size and single-stream collection, which is why this should change. Glass manufacturers should be making an effort to encourage others to recycle their glass and keep them separate from other recyclables. By separating our recyclables, we will not only help the glass recycling process, but also the process that other recyclables undergo by keeping them cleaner. Not many places recycle glass, which, again, makes recycling glass more inconvenient. However, Target is a place that I know of that will accept your recycled glass here in Brownsville. Hopefully, in the future, more places will begin to recycle glass. I believe that the most important thing to take away from this presentation is that glass is 100% recyclable. It is the most important as when glass is recycled, it is crushed and broken, turning it into cullet. Recycled glass cullet accounts for 70% of the raw materials needed to create the millions of glass containers used every year. Then, for every 10% of cullet included in the glass-making feed mixture, the energy needed to keep the furnace at temperatures high enough to generate molten glass falls by nearly 3%. These are all great things, but it all leads back to the fact that in order for cullet to be created, we must recycle glass. Because glass is 100% recyclable, we should always try to recycle glass, as we can see from this presentation that recycling glass can go a long way.